Lesson 8 goes over two-dimensional arrays, which sometimes are called a matrix. And it's really a very similar syntax to a one-dimensional array, but now everything will be subscripted twice, and that's the idea of the two dimensions. So if you take a look, I've got some sample code here, and this looks a lot like an array of strings, but you'll notice I have two sets of brackets. And that's what we mean by two-dimensional or doubly subscripted. This is what makes it a 2D array. And when I put these numbers here, these are my two dimensions. All right, so what's meant by those two dimensions? Sometimes these are referred to as rows and columns. So we would say that this matrix has 3 rows and 4 columns. Another way to think of it is that this matrix is made up of 3 different arrays, each of length 4. So a two-dimensional array means that you're going to put one-dimensional arrays inside of some other array. So this particular array called stews is holding 3 one-dimensional arrays, and each of those one-dimensional arrays holds 4 different string values. Okay, and that's what this means to be a two-dimensional matrix. Now, ultimately, that's 12 items, but the indexing is different. So instead of numbering them from 0 to 11 across one dimension, just think of like a coordinate plane. You have kind of like an XY axis, like an ordered pair, essentially. However, here, if we were to represent this as a rectangle, 0, 0 would be like your top left corner, and then 2, 3 would be your bottom right corner, because that would be the bottom row and the far right column. So typically we number our rows from top to bottom, 0, 1, 2, and we number our columns going from left to right, 0, 1, 2, 3, 4, whatever. And just like before, if I have 3 rows, they're indexed to 0, 1, 2. There is no row 3. If I have 4 columns, they're indexed to 0, 1, 2, 3, not 1, 2, 3, 4. Okay, so if I want to modify the contents of a matrix, just like I modify the contents of a one-dimensional array, I use the assignment operator. Okay, this is not like an array list. We don't have a set or an add method. So we use the assignment operator, but we have to say specifically where we're putting it in that matrix. And then if we would like access to a two-dimensional array, we have to specify where we're getting this stuff from. I've got a few various things going on here. Let's take a look at some of this output and see if we can make sense of it. So you can see this array was built to hold 12 strings. I only gave it 4. Now, the other 8 strings potentially could be there. If you recall, this would default all of those strings to null. Okay, like if we had an integer or a double array, it would default to 0. Boolean would default to false. Everything else defaults to null. So if I access any of these 4 string locations, I'll see Tom, Sue, Peggy, or Fred. And we see that, for example, like right here, stews 1, 2 retrieved Sue, 0, 0 retrieved Tom. But notice that 0, 1 came back and said null. And the reason it did that, like I said, was we never actually initialized that value, so it fell back on its default value. Here we got Tom, and here we got Sue. Some of these other prints may be a little bit interesting, like these first 2 really look bizarre, okay? These are memory addresses showing up again. Remember, unlike array list, arrays don't have a nice formatted 2 string for us. So if we ever print an array, we're going to get back a memory address. That first one, you see how there's 2 brackets on it? That's because it recognized that this was a 2-dimensional array. If you look at the second one, there's only 1 bracket on it. That's kind of interesting. That's because I asked it to print one of the arrays found in the 2-dimensional matrix, and it retrieved it as an array and then kind of told me like, oh, this is a 1-dimensional array. Unfortunately, it didn't know how to print it, so it just threw a memory address at me. Here I've called the length operator that we learned about back in one-dimensional arrays. Remember, it's not a method, so it doesn't end in parentheses. And I called it 2 different ways. Here I called it on the matrix, and here I called it on part of the matrix. Okay, so the difference is if I say stews.length, that's telling me the length of the two-dimensional array, which is how many arrays are in that two-dimensional array. How many one-dimensional arrays are in it? There's 3. Each row can be thought of as a one-dimensional array. That's why we see the number 3. And the reason that this tells me 4 is because that was saying if you took the particular row found at index 1, its length is 4. If you remember, we said that this matrix had 3 rows of length 4, 3 arrays of length 4. That's why we're seeing the 4 print there. What if I did something silly like this? What if I just made a matrix, but I didn't initialize it? We're going to get that kind of dreaded null pointer exception like we've seen before. Okay, it's going to tell me that this might not have been initialized. So whenever you make a matrix, you have to initialize it before you can use it. So this here is telling me that I hadn't yet initialized that matrix, therefore it wasn't ready for use. So same thing we've seen before with instance fields. If you have an instance field that's a matrix, make sure your constructor initializes that matrix prior to you trying to use it. What if I had put 2 subscripts here and called the length method? That won't work because if I put 2 subscripts on stews, it will retrieve an item from the matrix for me, which would be a string. String doesn't have a length variable. String does have a length method. So since this matrix holds strings, I could apply length method to a particular string, just like I could do, say, substring. Okay, so I could say something like substring. If I did substring 1, 2, which is Sue, and let's say I put a 1, 2 here, that would go and retrieve the letter U from Sue's name. Anything that comes out of this matrix can be handled as any other string that we've dealt with before. So we could do index of, dot equals, compare to, any string method, okay? But earlier what I was doing was a little different. I wasn't applying a string method. I was saying I would like the length of one of the arrays that belongs to this matrix. This matrix has 3 arrays. They're indexed to 0, 1, and 2. I was taking the length of the array at index 1. That might seem silly to you if you're kind of watching this, because you might think, well, isn't that the same as the array at row 2 and the array at row 0? And yes, it is. They're all length 4. This is what we call a rectangular matrix. Matrices don't technically have to be rectangular. I could have a matrix with arrays of length 3, 4, 5, 6, whatever. Those are sometimes referred to as jagged arrays. On the College Board AP test, you won't see any jagged arrays. All arrays will be rectangular. That's a given for your AP exam. It's not always a given, just for your test purpose it is. Okay. Here I've used Initializer list to make my matrix. Okay, maybe a little bit easier to visualize. And you can see here, I'm creating an array of doubles. It's 2-dimensional because I put 2 sets of brackets, double subscripts. That's what makes it 2-dimensional. That means that I can put arrays within an array. And that's exactly what I've done. This is an array of 5 doubles, okay, followed by another array of 5 doubles. So I have put 2 arrays inside of an array. Okay, we could also think of this, if you'd like, we could maybe show this on the screen a little bit differently. Okay, now that looks a little bit more like a matrix that's got 2 rows of 5 columns. Right now, if I printed dubs.length, okay, I'm expecting it would give me a 2. And if I printed dubs0.length, I'm expecting it would give me a 5. And the reason I'm getting 2 and 5, okay, is there's 2 arrays. That's the length of the matrix. And each array has 5 values in it. So that's like your number of columns. And that's that 2 and 5 that are showing up right there. Remember, if you try to print a matrix or one of its rows, you're just going to get a memory address. So unfortunately, that doesn't print real nicely. We'll have to use loops if we want to print the values, and we'll individually access all of them. And I'll show you that in a bit. Here, I went with 3 values retrieved from the matrix. Okay. I didn't get any nulls this time. When you're using an initializer list like this, you're putting in the actual values of the 2-dimensional array. Had I not done this, had I done something more like I did here, the matrix would have been filled with zeros, and then I would have had to have set all of the values individually, like I was doing with the strings. And I could have used initializer list on my string matrix as well, as long as I just made valid string arrays to put in there. I could quickly modify this, matrix here and maybe give it another row. So imagine like if we took this row right here and copied it, and then we could just go ahead and put in another row. Okay. And then, if you wanted to change a few of the values, you could. But ultimately, now the only thing that's going to change really here is this 2 is now going to become a 3. Okay, the 5 is going to stay the same. We still have 5 columns. If you count your columns from left to right, columns are considered to be vertical. So you have 5 vertical columns and you have 3 rows going across. Also notice that there's 3 arrays within the overall matrix, right? There's one set of braces, that's your overall array, and it holds 3 individual arrays separated by commas. See the 3 showing up now? That 3 is because I added that extra row, and so now I have 3 rows instead of 2. Oops, and I still type 2. Okay, so I've shown you that if you wanted to print a matrix, it's not as easy as printing an array list because we don't have a nice 2 string. And so that's why we're getting these weird memory addresses when I've asked to print the matrix. Okay, if I wanted to print these values that you see right here, okay, sometimes when we access all of the elements of a matrix, we do so in row major order. Sometimes we do so in column major order. And we might even do something else. Maybe you do like a spiral where you go around the edges and end up in the middle, or like a telescope or a snake order where you kind of go left to right and then come back right to left. There's lots of different ways that we could access, but these are the 2 common ones. Row major, you start in the top left corner. You work from left to right across your first row. When finished, you go to the second row, access all of its values from farthest left to farthest right, onto the third row, and so on until you reach the bottom. Okay, column major order will also start in the top left corner, but we'll go vertically down the first column, the one on the farthest to the left. When we reach the bottom, we'll go back to the top, and we'll do the same thing with column 1. We'll go from its top to its bottom, column 2, and so on. If we'd like to write code to see this, it's pretty easy. Okay, think about when we were first writing loops to interact with a matrix. We had kind of a standard loop that we used over and over and over. Okay? I'm going to work with the dubs array. All right. Remember, it really is array. It's just a 2-dimensional array. So if I was just working with a 1-dimensional array back in unit 6, and it was called dubs, this loop right here would take me to all of the indexes of that 1-dimensional array. I'm actually going to use that loop today. Okay. That loop is going to first go to this particular array within the matrix. That's what is at dubs 0. Okay. Then that loop could be used to access this particular array. And then finally it would run here. The value of dubs.length, remember, is 3. Okay, we saw that right here when we printed it. So if we ran this loop, it would go for 0, 1, 2, but not for 3. I could use those indexes 0, 1, and 2 to access the 3 different rows of the matrix. Okay, but what I would need is I would need to then write a second loop. This loop's going to operate on the interior. It's going to start at 0. It's going to go across the length of dubs. But if I said dubs.length, then this loop would also run for 0, 1, 2. And I don't want that because this is not a square. This loop has to go from 0 to 4 because that's the indexes of the values that belong to any particular array within the matrix. This array that I have highlighted right here could be accessed as dubs bracket 0. And then I could subscript it a second time, go to 0, 0, 0, 1, 0, 2, and so on to reach all those different indexes. So I'm actually going to change this. One thing I could do, I could put bracket I right there. Okay. What that would do is the first time that we ran this when I was 0, we would access row zero's length, then we would access row one's length, row two's length, and so on. And I just hit the wrong button there. Sorry. Okay, so here's what I'm going to do. I'm going to put a print line right here, and I'm actually going to use just a print method, okay, as opposed to a print line. And I'm going to access dubs at these two indexes that I'm generating, I and j. And I'll go ahead and put a space in as well, okay, so that my numbers kind of spread out a little bit. Now, remember, when you access a matrix, you give it two subscripts. The first subscript represents the row, and the second subscript represents the column. So actually, a lot of times in the future, I won't use I and J. You might see me name these row and column, or R and C, or whatever, okay? So typically, this index here would represent your row. So you might call it that, like R for row. Okay, this index here might represent your column. So maybe you refer to it as C or COL, or write out the whole word column, whatever you like. Okay, so now we're going to go and we're going to get stuck on this loop at 0. So imagine a 0 being locked in right here. And then this loop runs to completion, 0, 1, 2, 3, 4. We're going to access all of the values of row 0. And we're going to print them out with a space in between it. At some point, that loop's going to reach the end of row 0. So what I'm going to do is I'm going to put a system out print line right here. Because notice I was using a print method, so everything's going to be on the same line. Eventually, I'll want to drop to the next line. I'll do that after I'm done with this print. I'm going to change this back to R because I don't want to be stuck in row 0 forever. The next time my loop runs, I want to go to row 1, and then I go to row 2. And if there were more rows, I'd go to those also. We didn't do stuff like this with array lists because, array list had a nice 2-string. But if we want to print the values of a matrix, typically we're going to have to do that by writing our own loops. Again, this loop is considered in row major order. Now, sometimes I might write R there. A lot of times you might just see me put a 0 there. The reason is, again, the College Board has promised us that all of our matrices are going to be rectangular. So I don't really need to distinguish between row 0's length, row 1's length, row 2's length, etc. I can just grab row 0, take its length, and assume that all of the other rows have the same length because, again, the College Board has promised me that that's the case. I like putting 0 there. It's a little bit safer. I'll show you what I mean by that in just a second, because what I'm going to do now is I'm going to try to do column major order. It's going to print these values a little bit differently. We're going to see the values of the columns print first. So we should see 2.3, 4.4, 5.4 print. That's my first column. Then I'll see 5, 6, 3, 3, 6, 3. Okay, right now that's not quite what we're seeing. We're seeing that row come out. I want to see that column come out first. Okay, so what I'm going to do, it's actually really simple. I'm just going to borrow all this code, okay? And I'm going to change one little thing. I'm just going to switch my two loops right here. So I'm going to take my row and my column loops and kind of invert them. Now, what that's going to do is we're not going to pick a row and then access all of its values. We're going to pick a column, okay? We're going to get stuck there and access all of its row indexes. So I'm stuck in a 0 on the column right here. Well, my row index then goes through all of its cycle of values, 0, 1, 2. Then I would go to column 1 and go through all of its row values, column 2, and do the same. So if I had put the letter R here, like I was doing earlier, the problem is R hasn't been initialized yet. And so I'd actually get an error message as it tried to retrieve that uninitialized value. It doesn't understand this R up here. Remember, that R is local only to this loop. This is different. So I don't like putting R there. I like putting 0. Like I said, it's maybe a little bit safer if you then kind of start messing with your loops ordering and you want to do like the column indexes first. You're not reliant on that R being initialized yet. Okay, so now look at the difference. It's all the same numbers. They're just ordered differently. So we printed the values of the column first, then column 1, then column 2, and so on, all the way down to column 4, the final column. All right, you got some practice it problems you can take a look at, and they're pretty good. I'm going to set up like some more code writing assignments for you next week, but this week you want to be working on like CS Awesome, AP Classroom, and then take a look at the exit ticket.